So what do we got today?
Well, I have a review packet for my final,
Okay.
and so, I was thinking that we would do about half of it today, and then I would, instead of having a appointment, or like the tutoring session on Wednesday next week, can we have it Monday possibly?
Here, let's have a look at what my Monday is. Whoops. Hold on. Alright, here. Computer's a little slow here. Well, let's see. There's my Monday. You want to do 3 o'clock on Monday?
Can we do 2 actually?
Sure. That's even better, actually.
Alright.
Okay, so Monday, 2 o'clock on the 15th.
Yeah.
Alright. Alright, so what do we got today?
First question, determine the x values that cause the polynomial function to be 0, positive, and negative. And the polynomial function is x plus 5, x plus 3, and x minus 5. Right.
3 different?
Well, sorry, what?
So we're trying to take x plus 5 and determine when it's positive, negative, or 0?
Oh, it's all the whole polynomial is x plus 5 times x plus 3 times x minus 5. Yeah.
Alright. That's better. I use something called a line chart. Are you familiar with it?
I think we've gone over it. It might have been, it was probably earlier on in the year.
What are the critical points for this particular function?
Minus 5, minus 3, and 5.
If I put those on a line chart, and I'll go ahead and put 0 on here, although I normally leave 0 off. And I'll show you why. To determine whether this function is, well, to determine what this function is when it's left of minus 5. In other words, if I pick any number on the number line left of minus 5, let's pick minus 6. What is the function when x is minus 6?
It's 11.
We don't even need the number, we just need the sign. That's why it's a sign chart.
Oh, it's negative?
Uh-huh. In other words, and that's all we need to do is test one point. In other words, if I test minus 7, it's the same thing, it's negative.
Yeah.
Okay. Now let's test a point between minus 3 and minus 5.
Why don't we do minus 4? Because that's...
Okay, what's this when x is minus 4? Is that plus or minus?
That's plus.
What's this one?
Minus.
And this one?
Minus.
Which means that it is plus in between minus 3 and minus 5.
Wouldn't it be like opposites in each of the gaps between?
Probably in this one, but not always. In other words, you can have lots of different complicated functions. So really the only way to tell is to test each one with a point. What's a good point to use to test from between -3 and 5?
0.
Okay. When x is 0, that's plus, that's minus, so it would be minus everywhere. And then to the right of 5, I get plus, plus, plus. So there's your solution set.
Yeah.
So they want to know where it's 0. Well, it's 0 any of these points here.
Yeah.
It's plus right here and right here. And it's minus right there and right there. And
Yeah.
you can use interval notation or any number of ways to define that. And you're right, this goes minus, plus, but they don't always go that way. It depends on the function. If you have an x squared, then that's always going to be plus, no matter what.
Yeah.
So, all right, what else?
The next one is find the phase shift of y equals 2 minus 3 sine quantity 4x minus pi over 6.
Like that?
Yeah.
What's the standard function for a sinusoid?
Oh, y equals sine of x.
It's y equal a sine of b times x minus c plus d. Now, there are various standards, and this may or may not be the one you guys use. Sometimes the b can be inside the parentheses. Sometimes it can be a plus c. Does this look familiar?
Yeah.
Okay. So if this is your standard, c is the phase shift.
And that would be 30 degrees.
Yes. Plus 30 degrees. In other words, 30 degrees to the right.
Yeah.
Okay. In other words, if I wanted to rewrite this in this format, then I've got to do this. Notice the b is inside. Let's take another look at this. 30 degrees is not the phase shift. In other words, when I wrote the standard, I wrote it with the b outside the parentheses, but the function they give you, the 4, is inside the parentheses. And it makes all the difference in the world. For me to get this function into the standard format, I've got to factor out a b. And that changes the phase shift. The moment I take that b outside the parentheses, then the phase shift is no longer c, it's c divided by b.
Yeah.
b is 4 here, c is pi over 6, so pi over 6 divided by 4 is pi over 24.
Yeah.
In other words, this function that I wrote here is the same as what you gave me. Only it's in standard format, and it matters because in standard format, c is the phase shift. In the format you gave me, c divided by b is the phase shift. So whether this b is inside or outside the parentheses matters a lot.
Yeah.
All right. So instead of 30 degrees, that's 7.5 degrees, 1/4 of 30.
Yeah, that's a huge difference between the phase shifts.
It really is. And let me write the 3 different ways that you can write the standard. In other words, depending on whether you're in Colorado Springs or Denver or Chatfield, you're going to get the following formats. And there is no one that is correct. It's just knowing which one you're using. In number 1, C is the phase shift. In number 2, C over B is the phase shift. And in number 3, minus C over B is the phase shift. And the format you gave me was this format right here. The B was inside the parentheses, so the phase shift is C divided by B.
Yeah.
All right. What else?
All right. Find the vertical translation of y equals minus 3 minus 3 sine quantity 4x plus pi over 4. Would it just be down 3?
Uh-huh. They're
Right.
trying to trick you by giving it to you in this format. That doesn't fit any of the 3 formats, but the associative property holds, and I can put the minus 3 at the end.
Yeah.
And its D is minus 3.
All right, and then the next one is find the period of y equals 5 sine quantity 1/4 x minus pi over 2.
Okay, looks like your school system uses this middle format. In other words, format number 2. This one right here.
Yeah.
You tend to, all the problems, the B is on the inside, which is fine. It does not matter. It just means we have to change the definition of phase shift. All right, what did they want here?
They wanted the period.
Okay, the period is related to B. So B is equal to 2 pi over the period, or the period is equal to B over 2 pi. Notice they're the same.
Yeah.
Okay, so B here is 1/4. So what's the period?
The period is 1/4 over 2 pi.
Which is 1 over 8 pi.
Yeah.
Okay.
Next one is find the exact value of the real number y, and then it's y equals arc sine negative root 3 over 2.
Okay. You and I haven't done much with inverse sine, have we?
Not much.
Okay. If we take the sine of an angle and we get a ratio. In other words, if you take the sine of, say, 30 degrees, you get 1/2.
Yeah.
That is true if and only if the inverse sine of the ratio is equal to the angle. These two things have to both be true. So if I take the sine of 30 degrees, I get 1/2. Therefore, the inverse sine of 1/2 equals 30 degrees.
Yeah.
That's the definition of inverse. But it's important to know that whenever we're doing the inverse sine, we're taking the inverse sine of a ratio and coming up with an angle. Which angle is the sine of that angle equal to root 3 over 2?
Sorry, you worded that wrong. Or like weirdly,
I
weirdly.
did word it weirdly, but I meant to word it weirdly. The sine of what angle is equal to root 3 over 2? Let's start there.
The sine of that angle is 60 degrees.
Sine of 60 degrees is root 3 over 2.
Yeah.
Okay, but this is negative root 3 over 2. So we need to find the quadrant where sine is going to be negative and it's the equivalent angle of 60 degrees. Which quadrant is the sine negative?
Sine is negative in both the third and fourth quadrant.
Correct. So what is the third quadrant angle?
The third quadrant angle is that would be plus 2 pi, so
Hold on, this is pi here, or 180, 90, yeah. And this is 270. So if I had an angle of 240, I would be in the third quadrant, and it would be the same reference angle as 60.
Yeah.
In other words, I can use formulas here. Oops. Excuse me. In other words, if I have some angle and I want to figure out what its equivalent first quadrant angle is, then I'm going to use this graph here.
Yeah.
In other words, if I had a 240 degree angle, if theta was 240, then its equivalent first quadrant angle, I would use that, would be 60. So one angle here is 240. Remember, when we take inverse sines, we find angles.
Yeah.
What's the other angle?
The other angle is 300.
Now, if you use your calculator and you said, what is the inverse sine of negative root 3 over 2? It only gives you the fourth quadrant angle. Even though both of these are true. if you say, go into your calculator and say, what is the sine of 240 degrees, it'll give you negative square root of 3 over 2. And if you say, what is the sine of 300 degrees, it'll give you that same value. But if you say, what is the inverse sine of negative root 3 over 2, it uses the first quadrant for pluses and the fourth quadrant for minuses. Those are called the principal values. In other words, there's all kinds of angles where the sine of that angle is equal to minus root 3 over 2. There's also 420. In other words, if you type in the sine of 420 into your calculator, it'll also give you negative root 3 over 2. So there are multiple angles that give you this value. So when you do the inverse sine, it can't give you all of the answers. It's only going to choose one. And the one it chooses is fourth quadrant for sine. For negatives and positives, it would give you a first quadrant angle. If you go into your calculator and you say, what's the inverse sine of square root of 3 over 2, it's going to give you 60 degrees, not the second quadrant angle. Even though it's still true that the sine of 120 degrees is also square root of 3 over 2, your calculator doesn't give you the second quadrant answer. Your calculator always gives you the principal quadrant. And for sine and tangent, the principal quadrants are first and fourth. For cosine, the principal quadrants are first and second. So if you have an inverse cosine angle, then you're going to end up in a negative one. You're going to end up in the second quadrant.
Yeah.
All right. So did we get the answer? What was their exact question here?
Why find the exact value of the real number y equal 4y, and then y equals arc sine negative root 3 over 2.
So they said find the real value. Well, there's multiple ones.
It says value of the real number y.
Well, if you put that into your calculator, you're going to get 300 degrees.
Yeah.
But notice that 240 degrees also works as an answer. So they don't tell you what your domain is. But there's your two answers there, 300 or 240. Your calculator will only give you that one.
Yeah.
All right.
And then the next one is a similar question. It's inverse sine of root 2 over 2, which is going to be 45, a 45 degree thing.
That is the principal value. But notice that also is an answer.
Yeah.
If you go into your calculator and you type sine of 135 degrees, you get root 2 over 2. But if you type inverse sine of root 2 over 2, it's only going to give you 45 degrees.
Yeah.
Okay.
And then next one is find the domain of the given functions, and f of x equals root 8 minus x. Oh, root. It's yeah, there you go.
I realized it wouldn't be a question if that didn't extend all the way. So what can x be?
X can be positive.
Can it be a positive 9?
No.
What is that?
So it has to be less than 8.
Less than or equal to 8.
Equal to 8.
The reason
Yeah.
equal works is because you can take the square root of 0.
Yeah.
If I had this problem, the answer is x has to be less than 8. In other words, you can take the square root of 0, but you cannot take the log of 0. You can only take the log of positive numbers. So for the square root function, this is the answer. But just take note that the log function is more restrictive than the square root function is. Log functions, whatever's in the argument, has to be greater than 0. It cannot even be equal to 0.
Yeah. All right. And then same, give the domain of x over x. I think that's supposed to be x squared plus 3x.
Like that?
Yeah.
Can I reduce this?
No, well,
I can divide top and bottom by x. But I still cannot ever have x be equal to 0. In other words, in this function, x cannot be equal to 0, right?
yeah,
And yet, I can reduce this by dividing top and bottom by x. It reduces to this, but it does not take away the domain restriction. X can still not be equal to 0. It also can't be equal to minus 3. But merely because I factor an x out and cancel it does not take away the domain restriction. In other words, if I were to graph that, technically I need to put a hole there at x equals 0.
Yeah.
That's the hyperbolic function. And my vertical asymptote is at minus 3. My horizontal asymptote is there. The hyperbolic function looks like that. But in this particular case, there's going to be a 0 right there, a hole in the thing, to indicate that I can never let x be equal to 0. Now, if you graph this on your calculator, or if I were to pull it up on Wolfram Alpha, it's not going to show that hole.
Oh, the calculators do.
Oh, really? Well, you must have an Inspire.
No, I have a TI-83, but if you go to zoom decimal, there's a pixel missing in the graph.
Shows the hole. Interesting. I've never seen that. I didn't know they could do that. And the reason that the calculators typically can't show it is that it's infinitesimally small. Yeah. In other words, x equals 0 is just 1 point.
Yeah, like it, but in a regular window it won't show it.
Right, and it shouldn't because you wouldn't see it. But if you were to graph it manually or with a special calculator that shows holes, then you're going to see a hole there.
Yeah.
But the difference between a hole and a vertical asymptote is just this. In other words, if I did not factor out the x and I left it like this, then it looks like 0 is a vertical asymptote. But 0 really is not a vertical asymptote. Once I divide top and bottom by x, 0 becomes a whole, not a vertical asymptote. So it actually makes a significant difference in the appearance of the graph.
Isn't it that a whole is removable?
Yeah.
And then,
in other words, if I didn't remove it, I would have an asymptote at 0 and an asymptote at -3.
yeah.
Well, the asymptote at 0 gets removed and replaced by a whole. It's one way to look at it, I guess.
Yeah.
Okay.
All right, the next one is find the exact value of the composition sine quantity pi over 2.
Just that?
Yeah, and I mean, there are brackets around it, but on here, but I don't know if that does anything.
What's the sine of pi over 2?
Pi over 2 is 90?
Yes.
Yeah.
Here's your sine curve. Sine curve
yeah,
looks like that. And that's 0, that's pi over 2. That's pi.
90.
That's
and 1.
3 pi over 2. And that's 2 pi. In other words, that's a typical sine curve. If you're looking to memorize a sine curve, that's what you want to memorize, everything you see there.
Yeah.
It's 4 quarter points, and this means that it goes to its maximum at pi over 2. It's at 0, pi, and 2 pi. It goes to its minimum at 3 pi over 2, which is -1.
Yeah.
So there's only one spot in the unit circle where it's equal to +1, and that is at pi over 2. And I don't know why they put brackets around it. Sure there wasn't something else, like it wasn't pi over 2 minus pi over 6 or something?
No, in the parentheses it's just pi over 2. But around the entire thing, like even around the sign, there are brackets. So I think there might be something that didn't come out on my copy.
That's what it sounds like.
Because otherwise there wouldn't be a reason for the brackets.
There'd be no need for the brackets. Now, there is some cofunction relationships that I suspect it's talking about. Let's talk about those. What's the cofunction of sine?
Cosecant?
Cosine.
Oh yeah, and then tangent with cotangent, and then
all of
with cosine.
Right. In other words, to find a cofunction, just put the word co in front of it. But the cofunction properties are always this, and it works both ways. In other words, cosine of theta is also equal to the sine of pi over 2 minus theta. So these are true, and the same is true with tangent and cotangent and secant and cosecant.
Yeah.
So when you said sine of pi over 2, I was expecting a minus theta to follow it. And when you said brackets, I was really expecting it. So, in other words, if I want to know what the sine of 60 degrees is, it's the same as the cosine of 30.
Yeah.
Or if I want to know what the tangent of 60 is, it's the same as the cotangent of 30.
Alright, the next one is, it has the same thing. It has parentheses around the whole thing, and it's cosine quantity negative pi over 6. But there's nothing else.
It's all right. I'm not sure why they put the parentheses there, but it's like adding parentheses where they're not needed. It doesn't do any harm.
Yeah.
Now, it's also important to know which trig functions are even and which trig functions are odd. Sine and tangent are odd. Cosine is even. Their reciprocals are the same. In other words, the reciprocal of cosine is what?
The reciprocal of cosine is secant.
So cosine and secant are even. Sine and cosecant and tangent and cotangent are both odd.
Yeah.
So all four of these are odd. And what odd means is that if I have the sine of minus theta, it's equal to minus the sine of theta. And what even means is if I have the cosine of minus theta, that's actually equal to the cosine of theta. No negative sign.
Yeah.
So the cosine of minus pi over 6 is the same as the cosine of plus pi over 6. That's 30 degrees. That's root 3 over 2.
Yeah.
Now, you could do it the hard way. And by that I mean, well, minus pi over 6 is minus 30 degrees. Minus 30 degrees is the same as 330 degrees. Now, if I try to figure out the cosine of 330, I do 360 minus 330. So I'm looking at the equivalent of cosine of 30 degrees. It's in the fourth quadrant. It's going to be positive. It's square root of 3 over 2. That's actually 2 steps harder than using the odd-even property.
Yeah.
In other words, there's no need to translate this into a positive angle. So all I need to know is that the cosine of negative x is equal to cosine of x. So I don't need to go to the 330 degree angle to figure it out. And it saves me 2 steps not doing that.
Yeah. Alright, the next one is use a method of your choice to solve the equation, and its absolute value of 4x minus 11 equals 2. So,
whenever you have absolute value equations, best way to do it is to remove the absolute value sign and turn it into 2 different equations.
yeah.
So what does this mean? What 2 different things does this mean? It means 4x minus 11 can be equal to 2, or what?
4x minus 11 can be equal to negative 2.
Correct. And then just solve each one of them separately. So this x is 13/4, and this x is 9/4.
Yeah.
So both of those values for x will work. In other words, this one gives you 2 inside the absolute value sign, and this one gives you minus 2 inside the absolute value sign. Now, do you need to know absolute values and inequalities? In other words, if I
Yeah, but
if I said that was greater than 2, Now how do you solve it?
It's just 4x minus 11 is greater than 2, and then 4x minus 11 is less than negative 2?
Yeah, that's the only difference, is that when you have an inequality, you have to change the direction for the second part of it, as well as the sign on the number.
Yeah.
And then just solve each of these individually also. And it's also important that when you're doing equations that have an absolute value, that you check your solutions. There's three things that produce extraneous solutions. One is absolute value, the other is radical signs, and the third is logarithms. So if you have an equation that has any of these three, it's very likely you're going to end up with an answer, one of which will be extraneous and won't work.
Yeah.
Don't generally have that problem when you're dealing with a polynomial. In other words, if it's just a rational function. But it's these three things that tend to produce extraneous solutions.
All right. The next one is solve the equation, and it's 2 to the quantity 5 minus 3x equals 1/16.
Typically, when you have an exponential equation like this, in other words, this is not an algebraic equation.
Yeah.
We don't normally have techniques for solving this unless we want to use logarithms. And it's a problem where the variable is in the exponent that normally requires logarithms. I can solve this problem without logarithms because I'm looking at the same base. In other words, 2 and 16 have a common base. I can write 2 as 2, but I can write 16 as 2 to the minus 4th.
Yeah, and then...
Now, because I have the same base, I can equate exponents. So 5 minus 3x is equal to minus 4. Solve for x. No need for logs.
X equals 1/3. Or no.
Yeah, I think you're right, actually. No, minus 3x equals minus 9. X equals 1/3.
Okay.
Now, is all I have to do to make this unsolvable by that technique is to change that to a 15. Now I can't use that technique, and I'd have to use logs. In other words, if I ask you to solve this equation, well, the best way is to take the log of both sides. So I take the natural log of that side, the natural log of that side. That allows me to bring this exponent down in front on the equation line, and now I can solve it algebraically. In other words, this is just a number, that's just a number. So I've got a variable here and all these numbers, so I can solve it algebraically. But if you have a common base like we did, you don't need to invoke logarithms. And like on your ACT test and your SAT test, you will find problems like this. And yet neither test tests logarithms. In other words, you don't have to know logarithms for either test, but you will see some common exponential basis questions like this.
Yeah.
That you can solve without logarithms.
All right, the next one is Ooh. Find the asymptotes of the given function, and it's f of x equals x minus 9 times x plus 6 over x squared minus 9.
Okay. First thing you want to do is factor the bottom.
X plus 3, x minus 3.
Now what are the vertical asymptotes?
The vertical asymptotes are negative 3 and positive 3.
Yeah, vertical asymptotes are actually equations of a line. So it's really x equals minus 3 or x equal 3, which make up your vertical asymptotes. What's the horizontal asymptote?
The horizontal asymptote is 0?
It's 1.
It's 1,
and the reason is that you can have 3 situations for horizontal asymptotes. One situation is where the exponents, the highest degree exponents is the same, like this one. If I had this situation, then the horizontal asymptote is the ratio of the coefficients of that highest variable.
Yeah.
So it's 1, and that's what I'm looking at in our problem. If I multiply the numerators together, I have x squared. And it's only the highest degree that matters. In other words, it wouldn't matter if I had a 3x and a 7x with that, or a plus 12, or anything, minus 15. The only thing that affects the horizontal asymptote is the coefficients of this x squared term. And that horizontal asymptote is the ratio of those coefficients. So that's why it's y equals 1 in our problem. The other possibilities is if the denominator has a bigger power than the numerator, say this, as long as the denominators is bigger than the numerators, your horizontal asymptote is y equals 0 in all cases. Doesn't matter if this is x to the 4th or x to the 18th. As long as it's bigger than this, your horizontal asymptote is y equals 0.
Yeah.
The third situation is where the numerator is exactly 1 bigger than the denominator. When you have this situation, you do the division, and you end up with an oblique asymptote. Have you studied oblique asymptotes?
Yeah, we didn't do much with them.
Well, they look, say you had a problem that had an oblique asymptote and a vertical asymptote. Well, there's the vertical asymptote. The oblique asymptote is a straight line always.
Yeah.
And your function might look like this. In other words, it still approaches both asymptotes. As x goes to infinity, you're approaching this oblique asymptote. And as x goes to negative infinity, you're approaching this oblique asymptote.
Yeah.
So that's the only difference with oblique asymptotes and vertical and horizontal asymptotes. And you only get an oblique asymptote when the numerator is exactly 1 degree higher than the denominator. It doesn't matter if it's this situation or I could have x to the 7th over x to the 6th. As long as they're separated by exactly 1, when I do this division, I'm going to get a linear function, straight line, with some remainder. And the equation of the oblique asymptote is that linear function. You can throw away the remainder. It doesn't affect anything. But whatever the linear factor is, when you do this division, that's the equation of that asymptote.
All right, then.
Go ahead. Just
The
checking
next,
my appointment to see whether I had a 4 o'clock, and I do. But that's okay. We got 6 minutes.
Yeah, the last one we need to do is, suppose that theta is a in standard position and the given point on the terminal side of theta, give the exact value of the indicated trig function for theta.
Okay.
And it's 3, 4, and then find cosine of theta. So
When I draw the unit circle and I draw these angles, cosine of theta is always equal to the x-coordinate. The sine of theta is always equal to the y-coordinate.
So would it just be 3?
No. Hold on.
Oh, no, 4.
No, it's, you sure it's 3 comma 4?
Yeah.
Okay. This is not a unit circle.
No.
This is just a point. So it's, I have to complete the triangle, and if this is 3 and this is 4, then the hypotenuse is 5, not 1. If it was a unit circle, the hypotenuse is always 1. But in this case, the cosine of theta equals 3/5. And that angle is approximately 53 degrees.
Yeah.
In other words, if you have a 3, 4, 5 right triangle, the short angle, no, this angle, excuse me, this angle is the short one. That's 37 and that's 53. So yeah, theta is 53.
Yeah.
Approximately. It's 53 and change.
That's like...
Here's the classic trig problem. We got 3 minutes. Let me give you this problem. If cosine of theta equals 3/5, then what is the tangent of theta equal? That is the classic trig problem. And the solution is always the same. You don't want to draw a unit circle like I started to there. What you want to do is just draw a triangle and label a right triangle and label theta. Okay? Once you label theta, now if the cosine of theta is 3/5, then automatically I can do that. And once I've labeled 2 sides of this right triangle, I can figure out the other side. This has to be 4. So as soon as I'm able to dimension the entire triangle, I can give you any trig function. Tangent of theta is 4/3, cotangent is 3/4, and so forth and so on. So this is a classic problem, and the one thing they also usually add is what theta is, say, in the second quadrant. In other words, they'll give this information. They'll give you enough information to figure out what quadrant it's in. Well, if theta is in the second quadrant, cosine's obviously not 3/5, but it's minus 3/5. But I solved this problem exactly the same way. In other words, I draw a regular triangle, label theta, dimension the whole triangle, and now if I said, what's the tangent of theta? Well, I know I'm in the second quadrant, so it has to be negative 4/3. But I don't solve the problem any differently. I do it exactly the same way. I just draw this triangle and label theta and start dimensioning it.
Yeah.
Okay. Lucas, I will talk to you at 2 o'clock on Monday.
All right.
All right, have a good weekend.
You too.
Bye-bye.
Bye.